So my name is Andy, and I'm a rising senior at Lowell High School. And for my starter project, it is a light-seeking robot. And basically, when light reaches the robot, these photoresistors adjust their resistances, and that thus changes the current that goes through these motors. So basically, when I turn this on, this mode activates, which is a slow mode. So as you can see, it moves slightly. And when I cover up one of the photoresistors, see it's kind of turning this way, but it makes it difficult to turn. And then there's a second mode, which makes it move a lot faster. And that's not because yeah. And this project, biggest challenge was getting the motors to turn correctly, because I remember one motor turned significantly more than the other. So I had to adjust the sensitivity on these three potentiometers here. And the second problem was just, not really a problem, but just like, the main thing I had to do was a lot of soldering, as you can see at the bottom. There's a lot of soldering. And yeah, I soldered some components incorrectly, like backwards. So that was fun. I finished this in about 3 days. And so for my main project, it is a micro wind turbine. So basically, here's two acrylic discs. Gears here, aluminum rod, and attached to the sails here and the sail holders here. So when I turn this, you see the LED lights up. And the biggest challenge for this, well, there's two main challenges. The one was getting the sails actually in here, because these are aluminum sails, so it's very difficult to bend and stick it in these slots. So I put these side ones first, and then put it in the center. And my most major problem was the motor itself. Like, it started working in the beginning when I did my first milestone, in which I powered the breadboard solely using, powered the LED on the breadboard solely using the stepper motor, but it's turning the shaft. But then, for some reason, it stopped working, and I'm guessing it's because when I accidentally stripped one of the screws, I probably used too much force. So that ruined the internal components, and that delayed my project for about 1.5 weeks. Yeah, so, but in the meantime, while doing my parts, I decided to make a SolidWorks model of it. So I guess I'll show it. Okay, so explain my second project. Okay. Alright, the second project I decided to start was an omnidirectional robot. And that was inspired because I was involved in my solar robotics team, and I really like doing a lot of work that's what pretty much motivated me to come to Boost Engineering. And basically here's 3 servos here, and connected to these wheels. And the wiring is pretty complicated on this robot, as you can tell here. Yeah, that's the bad thing about using Arduino Uno, but so basically it's supposed to be powered by a PS2 controller, but then sadly 10 minutes before 7 o'clock. And yeah, too much friction over there, sorry, but yeah. Yeah, that's my robot. And major challenges with this was accidentally shorting my circuit a few times, and I had to shut it like twice for shorting. Yeah, that's one major problem. And the second one was just having 2 wheels turn significantly faster than the last one over here. But then now the only problem is the camera friction. For that, it didn't turn at the same speed altogether. And what I did was connect the ground on the Arduino to the ground of the breadboard, and that's all the problem. And explain. So the battery. So this is the battery to power the Arduino, and then under is a 7.2 volt battery that's used to power 3 motors. And yeah, it'll be a lot cooler to show using a PC controller. That's all I can do. Oh, it doesn't matter. Alright, that's cool. I can just show it, I guess. Alright. I guess I'll show my SolidWorks model over here. So basically this is a SolidWorks model, and just ignore the crack over here. It's just a pixels. But then, so basically basically, here I have, so the materials here are going through different colors, and that's made to reflect reality, the aluminum sails and the acrylic cut pieces. And so when I turn, yeah, I'm sorry about you, but when I turn the sails, just like in real life, you know, you see that these are turning. It doesn't anymore. Yeah, they're turning. And yeah, the big challenge with this was getting the fins, getting sails to turn the gears, and yeah, they were giving me a lot of error messages, and the key mate that allowed me to do this was introducing a plane on the rod, introducing a plane on the sails, and then locking them perpendicular mate, so they're forced to like be perpendicular the whole time. And yeah, that's my Slideware model, and I did while I was waiting for the motor to go. And that's basically it. Yes.
Was it hard to learn how to do the SolidWorks stuff?
I actually been slightly involved with it, like about 2 or 3 weeks at the robotics team, and I learned like basic parts. I learned how to make parts, but I didn't really know how to make assemblies. Like they were really confusing to me, and then I'm really glad that Sabrina was really helpful in it. Like she taught me a lot of assemblies and stuff. So I'm really glad that it's results. Any questions?
So do you actually compete for role against the other school on the robotic team?
Yeah, the first robotics team. Last year, we were one of the semi-finalists, but then we got beaten. Teams, but it's only our second year, so.
Oh.
Do the turbines work if it's windy outside?
Sadly, in San Francisco, the wind isn't as strong as I'd like it to be. So, like, there were a few times when it kind of turned a little bit and it was really faint, but it's hard to get enough wind. So, like, next steps for this, if I had more time, is to probably try to minimize the amount of friction along when I turn it, and also, try to adjust the gear sizes so that one big, one small, find a great gear ratio so that makes it more efficient. And yeah, for the robot, the next few days, I hope to troubleshoot the column because the coding worked this morning, and then yeah, I was actually able to drive it slightly, but yeah, I got it working.